Hey folks, welcome to the DarkHorse podcast live stream extra special Tuesday edition. Is it Tuesday?
It's Tuesday.
Extra special Tuesday edition. This is the 171st,
Second.
172nd live stream that we have done. Yet, in all that time, I have remained Dr. Bret Weinstein, you, Dr. Heather Hying, and we are here, having just returned yesterday from a fantastic excursion, ready to confront some of what has happened in the meantime and other issues arising.
Of which we may say a little bit here at the top of the hour, but you're not going to call me out on 2nd?
You didn't call me out on 71st or whatever I said.
That's true.
Yeah, so
How dare you not correct me, sir?
It's like a microcosm of mutual assured destruction. We have both erred, and neither of us are going to point it out, and presumably no one in the audience is paying close enough attention to notice.
I think that's probably right.
Yep.
All right. So here we are. We are not going to do a Q&A today, but we'll be back on this Saturday, and we will do our usual live stream and our usual Q&A at our usual time, 12:30. Our dog is walking around wondering why we haven't provided her a place to sleep. I apologize. She's going to have to stay awake for the whole thing, and usually we put her to sleep. So you can't say that about dogs. Usually, we provide a sort of a soporific effect.
Yes, the means for sleeping should the dog decide to do it.
Yes. Maybe she'll jump up on the table and sleep right there. All right. Today being Tuesday, which is the day that I always post to Natural Selections, I've got a new post today, and I want to say a few things about that too after we do all the top of the hour stuff. But as always, you can find me at naturalselections.substack.com. We have our book, Hunter-Gatherer's Guide to the 21st Century, and we are, of course, supported by you, our audience. We encourage you to subscribe, like, share videos that you are seeing on YouTube or Odyssey, or if you're listening on any of the normal places that you might be listening rather than also watching a podcast. And you can also consider joining one of our Patreons. We have monthly conversations. You have monthly conversations with a select few at yours, and we do private Q&As at mine. And on both of them, you can also get access to the Discord server, where there's lots of great conversations going on all the time. And of course, we have sponsors. As usual, we start off top of the hour, 3 ads from sponsors whom we really do actually vouch for. Here we go. All right. Our first sponsor this week is brand new to us, Cured. C-U-R-E-D. Cured makes nootropics in a market increasingly full of such products, but Cured sent us several of their lines, and I have tried and benefited from many of them. Today, I want to specifically talk about their product called Rise. Designed to be taken in the morning or whenever mental clarity, energy, and focus is your desired state, Rise was formulated by Cured's own in-house clinical herbalist. I've tried it several times, and each time find a subtle but definitely noticeable difference in my tendency to stay on task and get things done quickly and efficiently. I truly appreciate this product, Rise by Cured. Ingredients in Rise include lion's mane for mental clarity and energy, cordyceps to enhance oxygen utilization, not to make you turn into a zombie in the Amazon, which other cordyceps fungus do, but this is a different cordyceps.
It's a broad genus.
It's a big clade. Yeah,
wide range of effects.
That was just for those of you who have more familiarity with Amazonian fungus than you do with nootropics, which is, I think, 2 of us.
Yes,
perhaps.
And we're here, but okay. I gotcha.
Thank you. Yeah. Thank you. So ingredients in Rise include lion's mane and cordyceps and CBD and ginseng and Huperzia serrata, which I found that interesting. I thought, I don't know what that is, so I looked it up, and check it out. Huperzia serrata, which is the Latin binomial scientific name for a club moss that has been used in Chinese herbal medicine for a long time to alleviate memory loss and reduce inflammation, and derivatives of this very same species have begun to be used in Western medicine to treat Alzheimer's disease. So this is a memory-enhancing club moss plant that has been used in both Chinese and Western medicine, or the actual club moss is used in Chinese medicine, and as is its wont, Western medicine has pulled out one molecule and is using that. Cured's Rise blend of functional mushrooms, adaptogens, and cannabinoids will leave your brain on fire, but in a good way. That was their line. I decided to keep it in there.
Brain on fire. Yeah, yep. Well, all right.
Yep.
Makes sense.
And it'll help you get your to-do list tackled. The values that Cured holds
It
highest.
will incinerate your to-do list.
Yeah.
With your brain on fire. I don't know.
I mean,
guessing.
Incinerate your to-do list could mean, to hell with this.
It's good either way. Either you
It's
nailed everything on it, or
I think you could use some Rise by Cured.
I suppose.
Their values, as stated on their website, are nature, responsibility, and service. And they say, quote, "We are more than just our products. We are stewards of the plants. We represent health as a combination of movement, mindfulness, and daily action." I like that very much. Cured also does third-party testing of all their hemp-derived CBD products and makes those test results available on its site. Such testing is not a legal requirement, but allows customers to be certain that Cured products are free of harmful contaminants like pesticides and heavy metals. Rise is only one of many of Cured's products. They also make Zen, a product designed for afternoons and evenings, a sleep bundle that incorporates CBD with their Zen product, and so many more. They are so likely to have the nootropic that is right for you. Right now, Cured is extending an exclusive offer to you, our listeners. You can get Rise or any of Cured's other fantastic products for 20% off by visiting www.curednutrition.com/darkhorse and use coupon code DarkHorse at checkout. That's CURED Nutrition, CUREDNUTRITION.com/darkhorse and use coupon code DarkHorse at checkout to save 20%. Seriously, try it. It's good stuff. It really is. Our second sponsor this week is MD Hearing Aid. MD Hearing Aid makes high-quality, simple, and effective hearing aids for a tiny fraction of what most hearing aids cost, helping bring audio clarity and capacity to people who might not otherwise be able to afford it. We don't have need for hearing aids, but we have a friend who does, so we asked her to assess this product carefully and honestly. She did, and her testimonial will follow. MD Hearing Aid was founded by Start that paragraph again. MD Hearing Aid was founded by an ENT surgeon who made it his mission to develop a quality hearing aid that anyone could afford. He keeps the price low by simplifying the product, removing several rarely needed components, and he made a product that aims to fit so well no one will know you're wearing it. Other features include rechargeable batteries that last up to 30 hours, water resistance in up to 3 feet of water in their Volt Plus model, and you don't need a prescription to get one. MD Hearing Aid has cut out the middleman, so you buy your hearing aid directly from the source, where audiologists and licensed hearing specialists are available 7 days a week. Everyone can empathize with what it feels like to be left out of a conversation that others are enjoying. Here's a testimonial from that friend of ours who has substantial hearing loss and who relies on hearing aids. We asked her to try this product, and this is what she said. "With my particular type of hearing loss, a deep male voice in a noisy room is the hardest situation for me to hear and understand speech. I wore the MD Hearing Aid to have a conversation with a deep-voiced man in a room with a lot of white noise. The MD Hearing Aid passed the test. As my conversation partner's voice was clear and understandable, at a price point of under $1,000, I was amazed at how effective they are." MD Hearing Aid is bringing affordable hearing to hundreds of thousands of people who might not otherwise be able to afford high-quality hearing aids. MD Hearing Aid recently cut their price in half. So if you want MD Hearing Aid's smallest hearing aid yet, go to mdhearingaid.com and use promo code DarkHorse to get their new buy one, get one deal. A pair of hearing aids cost just $149.99. Plus, DarkHorse listeners receive a free extra charging case, an additional $100 value. Again, head to mdhearingaid.com and use promo code DarkHorse to get their new buy one, get one deal. A pair of hearing aids for only $149.99.
The charging case. Do we know if it is a hard case?
I'm going to assume so.
Then we should call it a hard charging case, I think. That would be cool.
Yes.
Right?
Note to sponsor. Hard charging case.
Hard charging case. Right. Be the first one in your block. All right. Our final sponsor this week is Vivo Barefoot, who make shoes for feet. Everyone should try these shoes. Most shoes are made for someone's idea of feet. Vivos, however, are made by people who actually know feet. And word is spreading. People often approach us because of the Vivos we're wearing, saying they've heard they're good, and they are. These shoes are every bit as good as you have heard. You will love them. Here at DarkHorse, we love them. They are beyond comfortable. The tactile feedback from the surfaces you are walking on is amazing, and they cause no pain at all because there are no pressure points forcing your feet into odd positions. They are fantastic. Our feet are the product of millions of years of evolution. Humans evolved to walk, move, and run barefoot. Modern shoes that are overly cushioned and strangely shaped have negatively impacted foot function and are contributing to a health crisis. People move less than they might, in part because their shoes make their feet hurt. Enter Vivo Barefoot. Vivo Barefoot shoes are designed wide to provide natural stability, thin to enable you to feel more, and flexible to help you build your natural strength from the ground up. Foot strength increases by 60% in a matter of months just by walking around in them. Vivo Barefoot has a great range of footwear for kids and adults, and for every activity from hiking to training and everyday wear. They are a certified B Corp that is pioneering regenerative business principles, and their footwear is produced using sustainably sourced natural and recycled materials with the aim to protect the natural world so you can run wild on the solid surfaces of it. Go to vivobarefoot.com and use the code DarkHorse15 to get an exclusive 15% off. Additionally, all new customers get a 100-day free trial so you can see if you love them as much as we do. That's vivobarefoot.com and use the code DarkHorse15 at checkout.
So they're not Jesus shoes. Is that what you are trying to imply?
Here's the thing. I have tried them, and I fall right through the surface of the water, but that could be me. You know what I'm saying? Me and almost everyone else.
Yeah, I think it is you, but it's not just you.
It's not just me.
Yeah.
Right. No, that's right.
Yeah. All right. Well, you have, I think, a number of things you want to talk about today. I wanted to start. There's some stuff that if we get to it at the end, I'd love to, but I'd love to start by just talking a little bit about the season before you embark on some of your plans here. It is, those of you who are in the Northern Hemisphere will have noticed, spring. And the farther towards the pole you are, the greater the change in photoperiod you've been experiencing. And probably in the sort of middle range as we are, the more likely you are just to be in the full flush of spring at this point. So we were just away from the Salish Sea, from the San Juan Islands where we now live, for 9 days. And about 3 weeks before that, 2 weeks before that, we were away for another 9 days. And in each case, we thought, we are going to miss so much change here. And indeed we did. And it is just a remarkable reminder of the complexity and vibrancy of the planet we live on, to both be in a place and watch the changes every single day, and also to go away for a short period of time and return to a place that you know relatively well and see how much change has occurred. I mean, it's a little bit like parents watching their children grow versus grandparents who only see those grandchildren episodically. Oh my, how you've grown! Whereas if you've been there every day, you may not notice that the buds are bursting, the grass is shooting up, all of that.
Yeah, it's amazing how much change there was in a little over a week.
Yeah.
You know, the place just looks different, feels different, and the phase of what is going on ecologically is clearly moved on substantially.
That's right. So there are a number of natural history stories that probably we want to tell in more depth when you've got some of your, or Toby's even, our 17-year-old's photographs queued up to include some of them. But I would just like to mention the harbor seals that we get to spend time with nearly every day here, who show up and look with interest at our dog, at our Labrador, when she shows up on the shore with us. It makes me wonder what they think about what is going on land. I wrote at the beginning of this year that I didn't exactly make resolutions this year, but I wrote in Natural Selections on my Substack that I want to befriend seals this year, and I would like to, and we have been paddleboarding a couple of times out in amongst them. I don't need to make friends with sea lions. They're a bit more interested in demonstrating that they have power, and they also have much bigger teeth.
You want detente with sea lions.
Yes, very much want detente with the sea lions, but friends with the seals. And I think they might be interested, but they're really interested in the dog. It is as if they see a kindred spirit, meaning actually in this case kin, from not too long ago.
So I would just, for anybody who is wondering whether you are imagining things, the telling signature of their interest is that they're facing us. Almost any time you're out there, they're looking at us, and Maddie in particular is a focus. And
they turn their heads and watch her walk up and down.
Yeah. So they really do seem interested. There's of course a part of me that, worries if we took Maddie out on a boat if if we went in, if he'd be safe. But I do think it does look more like curiosity than anything.
Yeah, it really does. And we've also got bald eagles who are appearing to hunt gull eggs, as far as we can tell.
Gull or goose?
Yeah, it's hard to know exactly what all is going on out there, but I don't know that we've seen goose nesting in the place that the eagles go and flush the gulls off of. So this is just watching life come back into its own as nearly every organism at this point is about to start reproducing, or is in the middle of it, or is already protecting their young. Spring is inherently a time of great activity and ferocity, and we saw this up in southeastern Alaska where we were last week as well. About which again we will say more in the future, but specifically, we saw a number of sea otters with babies, which is just about one of the most adorable things you can imagine. And we saw sea stars. So I wrote about this for my Substack today, and I will link that in the show notes. But sea stars used to be incredibly common along the west coast of North America. I remember them from tide pools when I was growing up in Southern California. And we have been living in the Pacific Northwest now since 2002, and they used to be all over the place, encrusted on pilings in any kind of tide pool situation. And anytime you were in the water, such as kayaking in a shallow rocky shore, a shallow rocky intertidal habitat, you would find them. And
high diversity too. We're talking
incredibly high
about
diversity.
10 recognizable morphs. I don't know how many species, but
More than that even. Apparently there are. So the bit of research I did for my Substack today, there are 1,900 species worldwide, and this is not the hotspot for them. They're actually more diverse in, I think it was Indian Ocean especially, and maybe Atlantic as well. But there have been many species here, and about 2013 there was a massive die-off. And there have been some die-offs before. Of course, numbers fluctuate, but specifically the dominant, like the keystone predator, the first species that was ever called a keystone predator in the ecological literature, in fact, by Robert Payne, different Robert Payne than we went to.
The other.
The other Robert Payne. So there was a Robert Payne who was on the faculty, an ornithologist at the University of Michigan. This is the other Robert Payne. He literally wrote, and I don't have it up, but it's the ochre sea star, as such an effective generalist predator, that it was this species, that keystone predator was a term that was described for first.
So forgive me, I don't see color and don't pay as much attention. I don't know what ochre is, but
Like gold, brown, yellow.
Gold brown. So it's not the purplish one.
Yeah, and so this is the sort of conceit of my piece, which is short, and I encourage those of you to read it. It begins this way. I'll just read the first paragraph. Once upon a time, you could kayak the waters of the Salish Sea around Seattle or Vancouver, off of Whidbey Island or Orcas or Vashon, and find sea stars in a rainbow of colors. There were bright orange sea stars and others in salmon pink. Some were pale yellow. Many of them are rocky beige. Some sported an almost luminescent blue. There were even purple ones. Most had 5 arms, some had 6, and some had many more than that. There were sea stars visible in any clear water that was shallow enough to see the sea floor. Now there are almost none. And I go on and explain a bit about what sea stars are phylogenetically, and to what the die-off that began in 2013 has been attributed, and say, I don't buy it, right? That none of the supposed mechanisms that have been proposed for what is called sea star wasting disease seem fully explanatory. And to its credit, the research that I've read on this acknowledges that. People are kind of making stabs, and hopefully not entirely the dark, at what is going on there. But the experience that we had in southeastern Alaska this week.
Wait, before you move on to that, I just want to point out that as this was happening, as wasting disease was beginning to be recognized, this was something you could also observe The sea stars, as they disappeared, it wasn't just simply that their numbers dropped. You could actually go to the seashore and see animals that, were missing a limb and oozing, and it was quite sad and alarming if you were familiar with these things. And sometimes you would find one that wasn't wasting, and it was kind of exciting. And at this point, how many have we seen since moving up to the San Juans in September?
Well, more than we had seen in years, but I think we saw 3.
Yeah, it's a tiny number.
It was 1, maybe 2 in the previous several years.
Yeah, and it would literally have been every time you looked over a dock, you would see multiples. You wouldn't even realize most of the time. It was like background. It was like looking at trees.
Yeah, no, and the way that this syndrome affects these animals looks very excruciating. And apparently, I learned from the bit of research I read this week, the first sign is that they lose interest in food. So they stop eating first, and then their arms twist and contort. And we saw that too, right? They do but the most sort of grotesque part of it is the point at which their tissue seems to lose coherence, right? And they sort of ooze and melt and die. And then they disappear entirely, and they're basically gone. Except we were in a double kayak in a bay off of Chichikov Island, west of Juneau, south of Icy Strait, south of Glacier Bay National Park, this last week in shallow water, shallow, clear water at low tide. And we saw all sorts of stuff. We saw sea cucumbers and anemones and a little run of salmon, and a lot of clams opened up, clam shells, and again, a few otters on the surface of the water, and so many sea stars. And I don't know, I was not able to ascertain with regard to that spot if somehow they never died off there, or if they did and they're coming back. Because I have heard anecdotally from some number of people who say, yep, I'm on the Salish Sea, which is basically just the area that includes the Puget Sound and up into the San Juan and Gulf Islands. That includes Seattle and Vancouver as the biggest cities in the area. I've heard from people on the Salish Sea and the Sunshine Coast in British Columbia and farther south like Oregon coast who say, yeah, they were totally gone, but I'm beginning to see them back now. So it's possible that the colder water of Southeast Alaska, which is understood to slow the procession of the disease, but doesn't actually halt it in its tracks, maybe was a little bit protective. Maybe it didn't get so far. Maybe it's allowing them to come back faster. I don't know. I don't know if they were gone, they're coming back, or they were always there. But seeing the sea stars there gave me hope in a world that seems incredibly bleak across so many domains, including and especially ecologically. It really gave me hope. And, we were seeing that same, the conceit that I mentioned earlier of the pieces that I finish with clamshells littered the shallow sea floor. This is again on off Chichikov Island in Southeast Alaska, open and broken and scattered. But the other organisms that were not just present but abundant were sea stars. There were bright orange ones and others in salmon pink. Some were pale yellow, many of them are rocky beige. Some sported an almost luminescent blue. There were even purple ones. Most had 5 arms, some had 6, and some had many more than that. It looks like not a perfect match, but a similar match for the species that should have been there before, where we've never been before, but that we had seen in the Salish Sea some hundreds of miles south.
Yeah, absolutely. And yeah, I wish we knew whether or not that was a change or whether those were isolates that were preserved through the wasting disease. But yes, it sure would be wonderful if they returned. That would be a sign that whatever catastrophe had befallen them was passing, at least.
It absolutely would.
Yeah.
All right.
Excellent.
I've said my piece.
You've said your piece. All right.
Yeah, for now.
So I guess we're moving on to one of the things about this trip that we were on was that it cut us off almost entirely from the technological world, which was alarming at first because of
we just didn't know it was coming. It would have been wonderful to know that in advance, and we just didn't know it was going to happen.
Yeah. So there's lots of things
Correct.
One might,
Right.
put on pause somehow, and there was a scramble, and then connectivity disappeared. But
Yeah.
being forced away from connectivity was marvelous in its own way.
I mean, it's something we used to do to our students intentionally, but
Yep.
we gave them warning.
Yep, we sure did. But in this case, something happened while we were away that I might have missed, actually. I might have missed the thing entirely if somebody had not posted a link to it and tagged me in a discussion that I'm in. And what it was a New York Times article reporting on a new scientific result that was published in the New England Journal of Medicine. Zach, if you could put up the New York Times, the beginning of that article. Okay. The title says, "Link between long telomeres and long life is a tall tale, study finds." Now, when I saw that title, I thought, oh, brother, another supposed debunk of the hypothesis that I advanced in the very late 90s on the relationship between telomeres, which are repetitive genetic sequences at the ends of eukaryotic chromosomes. We are eukaryotes. Eukaryotic chromosomes are linear. They're not circles. And telomeres are repetitive sequences. They're not genes. They are just sequences of DNA that repeat at the ends of chromosomes. I'll get more into what they're about shortly. But in any case, when I saw this, I thought, okay, this is going to be another one of these articles where they claim, without pointing to my hypothesis directly, but they debunk the idea that telomeres mediate a balance between tumor suppression and tissue repair, the balance between them creating increased longevity. That's what I thought when I saw this title. And then I started reading the article, and holy moly, that is not what this article says.
The New England Journal of Medicine article or the New York Times article?
The New York Times article. I will get to the New England Journal of Medicine article that Gina Colada, the reporter who did the New York Times piece, is reporting on in a second. But contrary to the implication of that title, and I will say I think Gina Colada has a lot to answer for in this article. It's very poorly done, frankly, but she's probably not responsible for the title. The title is probably...
Well, and you've got a headline and a subheadline, and the subheadline looks to tell a slightly different story.
This subheadline does tell a slightly different tale. It says, the longer a person's telomeres, researchers found, the greater the risk of cancer and other disorders, challenging a popular hypothesis about the chromosomal roots of vitality. Now, I find that subheading also very misleading because the point is the telomeres are at the root of vitality, but it is not more telomere better. It's a balance, much as I argued back in the late 90s, and then with my co-author Debbie Cizik published a paper ultimately explaining the hypothesis and the evidence surrounding it. So if you will scroll down to that first paragraph, Zach. So this again is Gina Colada, one of the New York Times science journalists. She says, the story, as often happens in science, sounded so appealing. Cells have a molecular clock that determines how long they live. If you can just stop the clock, cells can live indefinitely. And the same should go for people who are, after all, made of cells. Stop the cell clock and you can remain youthful.
Well, I mean, but that paragraph is directly responsive not to your hypothesis, not to what you have published in the Journal of Experimental Gerontology back in 2002, but to the sort of pop medicine version of that, on which basis presumably tens, if not hundreds of millions of dollars of grants have been given.
Indeed.
Right? Like that is what she is reporting on there is truly something that people who ought to know better have been claiming all along. People who forgot or never knew that actually trade-offs in everything all the time.
Right. And it's one of the things that I was responding to more than 20 years ago was the fact that people were telling a biological story that made no sense. And the reason that that story made no sense, literally never made any sense, is that if it were true that the more telomere you had, the longer you live, then selection would have a very easy time lengthening telomeres. And so there was something implied, the limited length of telomeres. In fact, that limit evolved second. Our eukaryotic ancestors that were single-celled or colonial, like yeast, have telomeres that maintain their length. So that something in becoming a complex organism resulted in the evolution of limited length of telomeres that shrink with time or with cell divisions. And so it was always implied by the facts that there was some reason to have the telomeres shorten. All right. The question was, what was that reason? So let me read her second paragraph. She says, the clocks come in the form of caps on the ends of chromosome, the long twisted strings of DNA carrying the cell's genes. The caps on chromosomes, called telomeres, are chains of short, repeated segments of DNA. Every time a cell divides, its telomere gets a little shorter, until finally they get so short that the cell dies. Well, that's not true. Okay? That's just simply an incorrect description of what happens. It is true that cells, somatic cells that are not in a small number of special classes, do shorten with every cell division. But it is not true that when the telomeres get to a critical level of shortness that the cell dies. What happens actually is that the cells go into a different phase. And the paper that Debbie Cizik and I published argued that the interpretation that the field had thrown onto this second phase was incorrect. We argued that it was in fact an adaptive response to having reached the end of their capacity to reproduce. And the upshot of the paper was that the reason to have that limit was that it regulated the runaway cells where the repair capacity had been triggered to go into a phase that was unlimited and they would otherwise become cancers were it not for the fact that the telomeres shorten with each cell division and rein them in. We would be overrun by tumors.
Runaway cells being informal speak for cancer.
Well, runaway cells being informal speak for tumors, and then tumors become cancers when those cells start metastasizing and spreading around the body. But nonetheless, yes, it was tumor suppression versus tissue repair, telomeres being the regulator that balances these things, and the balance being the reason that we have such great longevity, right? You don't want long telomeres or short telomeres. You want balanced telomeres because they provide the optimal balance point between the two hazards. So what I'm getting at here is, it's very interesting. This New York Times report, again, reports on a New England Journal of Medicine paper, one that the New England Journal of Medicine thought important enough that not only did they publish the paper, but they published an editorial on it because the significance is so substantial. But what is so very odd is that this is reported as if nobody saw it coming, when literally my co-author and I published a paper more than 20 years ago. Yeah, let's show that paper. Yeah, you want to
Show
put it
my
up?
screen.
No, I got it.
Oh, you have it.
Show your screen.
So here it is. This is, and I should point out that you will see this is published in the Journal of Experimental Gerontology. The title of this paper is The Reserve Capacity Hypothesis, Evolutionary Origins and Modern Implications of the Trade-off Between Tumor Suppression and Tissue Repair. Now, this paper has a bit of a history to it. This is actually a publication in Experimental Gerontology following the rejection of a paper that was very similar to this by Nature, one of the two premier journals in the world. Nature preposterously claiming that the topic was not of sufficiently broad interest to their audience to be worth sending out for review. Nature actually officially refused to review the paper, in spite of the fact that the paper was sent to them. Yes, Debbie Cizik and I were both graduate students at the time, and they could have overlooked the significance of the paper, but it came to them with recommendations from George Williams, one of the greatest evolutionary biologists of the 20th century, who specifically recommended to them that they take it very seriously and review it, and a similar letter from Dick Alexander, my and Debbie's PhD advisor, a member of your committee, who also strongly recommended that they take it seriously.
And both, I presume Williams was, but both members of the National Academy.
Right. These were, you couldn't get a stronger recommendation for an evolutionary hypothesis than those two, and yet Nature flatly refused to review it. They sent it back saying it just wasn't sufficiently interesting. So after that happened, something that I have to speculate a little bit about occurred, which is that I got a letter from experimental gerontology saying that they had heard about the manuscript and that they were interested in us submitting it to them, which we did. I believe that that happened because George Williams must have contacted them back channel and told them that it was worth their time. In any case, they ended up publishing it finally in 2002. And in any case, it has been not widely discussed in cellular and molecular biology. And as you can see, it takes something like 20 years. And finally, cellular and molecular biology is catching up to the idea that there is a fundamental trade-off that is adaptive in nature. And there is enough of a hubbub about it that the New York Times is reporting on it. Now let's look at the paper that the New England Journal of Medicine published. So not the editorial, but the primary paper. Yeah, the original article. Okay. So the title here is Familial Clonal Hematopoiesis in Long Telomere Syndrome. And what this paper describes, so there's a lot of inside baseball here. There are various things that were predicted in my original paper that turn out to be true. Among them, the idea that moles are actually cells that have run up against their telomeric limits. We called them prototumors, which I still think is a great term that ought to be adopted, but I've never seen it used by anyone else.
Dermatological moles. Not Avogadro's number moles.
Not Avogadro's number or
moles.
Right, exactly. So I won't go into all of the detail, but what they have done here is they have done the flip side of another piece of work. So back when we originally published this paper, there was a question about whether or not progeria syndromes, that was accelerated aging syndromes, the worst of them being Hutchison-Gilford's progeria. People have probably seen images of these usually boys, these very young boys who appear to be very, very old.
They look like wizened old men.
They look like
they're patently 6, 8, 10 years old.
Yes, and they have virtually every pathology that comes with old age except for two. One of them is cancer and the other one is cognitive decline. So interesting that those two don't show up. That would be predicted by our hypothesis. But in any case, the reserve capacity hypothesis did not exactly predict what was going on with Hutchison-Gilford progeria. It turns out there was a second mechanism we didn't think of, but we predicted that Hutchison-Gilford progeria and other progerias would be the result of short telomeres. It turned out that people who had these disorders had normal length telomeres that shortened at an abnormally fast rate as a result of the fact that cells were produced but didn't stick. So if you had to produce 5 cells to get one that stuck, it resulted in a 5 times the rate of expenditure of telomeres. So, okay, if you have shortening telomeres that accelerate or accelerated in their telomere shortening, and it gives you pathologies of aging except cancer and cognitive decline, which presumably functions through an entirely different mechanism. What happens if you have very long telomeres? Well, that's what this is about. So they studied a syndrome called, can you scroll down to the abstract here? They studied a syndrome called...
Is it humans that they're looking
CHIP. Yes, they studied humans. It was actually, no, back up. Okay. So they studied people who have a germline mutation in a gene called POT1. Now, normal POT1 is involved in the shortening mechanism of telomeres that causes telomeres to erode with cellular proliferation. Mutations in this gene result in either additional telomere being added or a reduction in the rate of shortening. But either way, it results in somatic tissues out in the body, that have abnormally long telomeres. And lo and behold, what did they find? But they found that people who have this this mutation, we're disproportionately prone to certain types of cancers and a couple other pathologies.
Quote, a range of benign and malignant neoplasms involving epithelial, mesenchymal, and neuronal tissues, in addition to B and T cell lymphoma and myeloid cancers.
Right. Okay. Now, there's a lot in there, but the basic point is, the reserve capacity hypothesis turns out to be true. Short telomeres result, or shortening telomeres results in increased pathologies of age. Elongated telomeres result in an increase in the chances of developing a tumor or a cancer. So that is fascinating. Now, it's strange, though, that not only does the New York Times fail to mention that there was an existing evolutionary hypothesis that predicted exactly this result, but the authors of this paper also do not cite it, nor do the authors of the editorial about the result. They both ignore it completely, even though the editorial, for example, uses a term about the rescuing of cells from senescence by a mechanism that adds telomere, possibly involving the POT1 mechanism, the POT1 gene. So I guess, first of all, I don't want to be in a position of claiming that I know what the significance of this work is. That's not mine to say. We're not supposed to be describing that about our own work. On the other hand, what do you do in a world where you do work, you do it the right way, it is scientifically exactly what we are asked to do, which is to predict things and to demonstrate that what we have put into the world has explanatory power on this basis. Others are supposed to cite it. And what do you do?
Yeah, what do you do? There is a lot wrong with modern science, obviously, as we have spent a lot of time talking about here and elsewhere. The scientific process is often thrown under the bus in favor of accomplishing political ends that actually have nothing to do with science. We have talked a lot about how very non-fundamental and non-central peer review, certainly in its modern instantiation, is to the scientific process. In its modern instantiation, it being imminently gameable and thus gamed almost entirely. But citing those whose ideas you are invoking is absolutely necessary, not to come to know more things, but to keep track of where good ideas are coming from. And this is something that, this was one of the things that I used to insist on my students getting right. And, these are undergraduates everywhere from advanced undergraduates to freshmen who would almost always have the question, as most graduate students do, as frankly many probably practicing scientists and researchers do, and medical researchers do, under what circumstances do I cite? Like why are scientific papers such a damn disaster to get through for people who aren't scientific, because you always got citations in the middle and it impairs the ability to just read through, right? You cite any idea that is not common knowledge. Okay, that is easier said than operationalized, because at what point does something become common knowledge? There will be some disagreement at that categorical border, because the border itself is fuzzy, right? Well, most people agree on this at this point, but not everyone. Do I still cite the original? I would tend to err on the side of giving the credit if it's not really clear, but many people think, everyone, scientist or not, has in their head like plagiarism is bad. Right? Plagiarism is bad because ideas are not in the air. They emerge from individual people's brains, and generally they emerge from the collaboration between people's brains at the point that it's conscious. But we need to keep track of where the ideas are coming from and who's got the good ideas. And very, very often you find there's ways of doing less work, which is a kind of cheating in science, where you say, well, I know this is true, so I'm just not going to bother trying to figure the citation out. Sometimes that's what's happening. You also have oh, okay, this paper I'm reading, that's a good review, and so I don't have to go back and read the 700 papers they reviewed. I'm just going to read this review. Oh, they claim this paper written in 2012, this really good review paper published in 2012, and there's no reviews done since then, claims that this work in 1998 found X. Okay, I'm just going to claim that I read that paper, and I'm going to cite that 1998 paper about X. Well, when you actually go back to the earlier paper and look for the claim X, it is alarming.
How often it's wrong.
Alarming how often the claim that was made by the later paper just got it wrong.
Yep.
Right? And so if you are making a claim based on someone else's claim, the honorable thing to do, the honest thing to do, the only scientifically rigorous and careful thing to do is say, this claim was made by such and such according to this later person. But scientific journals don't want you doing that. They want you finding the original resource. They want you finding who said it. So where in all of this does your and Debbie's paper from 2002, which was based on work that you had been doing since the mid-late 90s, where does that fall into this? Somehow you got disappeared, right? Your work got actively disappeared, and it became totally, not just totally okay, but actually expected, I think, that your work, which is hypothesis-driven, theoretical, specifically makes a number of predictions that have been borne out in the years since. We will not talk about that. And that we will not talk about that thing among scientists, deeply anti-scientific, corrupt, and a problem for all of us, because that way is the end of science.
So this goes to a number of places. You hint at one of them when you talk about hypothesis-driven. Proper science is hypothesis-driven. Mm-hmm. Most people think that it's clever to say that their science is data-driven. As you and I have talked about, data-driven is actually a kind of a coup that has been mounted against hypothesis-driven science by laboratory types who have various reasons, perverse incentives for not wanting to be so closely obligated to the hypothetical realm. But this is a case, for one thing, evolutionary biology as a field has a right to be recognized when it succeeds in predicting things in the laboratory. In other words, is this just is it an abstraction? Is it like, studying distant quasars that it has no meaningful application on planet Earth? No, this actually has important medical implications and important funding implications. You have entire fields that have been studying what is obviously a dead end from the point of view of dealing with a pathology. They've been lying to each other about what is likely to work. Are we likely to extend life by increasing the length of our telomeres? Are we likely to cure cancer by getting our telomeres to be shorter, right? Those two things have to come together and be discussed, and the point is you need a proper theoretical context. How do you know what a proper theoretical context is? It makes predictions. How good are the predictions? I don't know. How much realm are they relevant to, and how early do they come?
And how risky were they? It sounds counterintuitive, right? But you want risky predictions, because a non-risky prediction, that couldn't possibly not be true, isn't much of a prediction. If the thing is almost certainly true under a whole array of circumstances, it's not much of a prediction. A risky prediction is true if and only if the hypothesis from which it comes is itself true.
Right. And there's a question about the, so the work that it turns out 20-some years later was predictive of this result that both the New York Times and the editors of the New England Journal of Medicine apparently think is very important, even if readers of Nature wouldn't have thought it was worth their time back in 1999. But the implications may extend far beyond those predictions. In other words, we don't predict things in order to see the results of an experiment early. We use experiments to figure out which models of the universe are actually closely aligned with an underlying reality that we can't observe directly. And so this particular work also came with another prediction about mouse telomeres. So Those who are longtime viewers of the podcast will know the story maybe more than they'd like to about the fact that what stood in the way of generating the model that was underlying the paper that Debbie and I ultimately published was the fact that there was a piece of evidence that could not be reconciled with it, which was that mice had ultra long telomeres that wouldn't make any sense if telomeres were mediating a balance between tumor suppression and tissue repair. You would expect a much shorter telomere in mice to deal with this trade-off in such a small-bodied animal. What turned out, ultimately, I predicted that what was universally believed at the time, that mice had long telomeres, that would be false, and that it would be discovered if we were to study the telomeres of wild mice, that they would have short telomeres just like people and other mammals. And so it would be a laboratory artifact that had created the long telomeres in mice that had been measured so many times. And if that was true, that had dramatic implications for not only the study of wound healing, of cancer, of senescence, all of the things that we would use mice as a model organism for, but it also had very direct implications for pharmaceutical safety, because those same mice are used to test compounds to see whether or not they are toxic, right? So toxic that you wouldn't want to release them as a pharmaceutical. Now, the problem is what I hypothesized was that a selective force in the breeding colonies from which laboratory mice come, based on the fact that younger mice breed faster than older mice, and because these entities that produce lab mice are sensitive to how expensive it is to produce a saleable mouse, they breed younger mice because it's more cost effective. What that does is it means that those mice in those colonies don't live long enough to get cancer. And so it takes this delicate trade-off and it unbalances it wildly in the direction of long telomeres are good because they reduce the pathologies of aging. So they are selected for in mouse colonies. But the problem is, if you take a mouse who has long telomeres, that mouse is condemned to get cancer. Virtually all laboratory mice die of cancer if you give them the opportunity. They live shorter lives than wild mice because they don't have this delicate balance. They're unreliable models of cancer because they're so prone to it that they are unlike people. But worst of all is they will be disproportionately resilient to toxins that are not so deadly that they outright kill the animal, right? A toxin that is just simply very bad for the animal, that kills tissue but doesn't kill the animal outright, is something that such a mouse can compensate for because they have effectively an infinite capacity to replace their cells. And worse than that, the fact that these animals are condemned to get tumors means that if you give them a toxin that is bad for them but not deadly, it may extend their lives by slowing down their tumors. It functions like chemotherapy because the way chemotherapy works is cells that are in the process of dividing are more vulnerable than cells that are in a static phase. So when you get chemotherapy because you have cancer, the idea is we give you a poison and it's bad for you, but it's worse for your tumor. And you kill the tumor faster than you kill the patient. In mice that have these latent tumors, giving them a toxin may extend their lives. And so when you say, well, is this compound safe enough to give to people? Well, I don't know. It extended the life of these mice. Maybe it's not bad. Well, maybe what you just discovered is that it's a toxin and that it's not going to be very good for people, and that mice are or laboratory mice are a very unreliable model.
So one of the many problems, is that there are so many like sign changes in that story that it's very hard to explain to an audience that isn't already informed. And the audience that is already informed, that is to say, those researchers who work on things like telomere and senescence and cancer, don't want to hear it.
Well, they don't want to hear it, but they don't have any right not to hear it.
No, they don't.
That's the problem.
But it's a story that is particularly easy for the public to miss. Not that the public hasn't been forced to miss a whole lot of stories that shouldn't have been easy to miss at all, but this one is easy to miss because it's going to be a really hard sell for a story whose soundbite is, this drug is bad for you, because it being poisonous helped the mice that it was tested on to live longer.
Agreed. But all I would say is, look, people in the public, this isn't their job,
No, it's
right?
not.
There are institutions whose job this is, right? The FDA should be absolutely obsessed with discovering whether or not this is an accurate description of the universe. Instead, the blue ribbon panel that was assembled after the Vioxx scandal put together a 300-page book called The Future of Drug Safety, in which telomeres are not mentioned, mice are not mentioned, rodents are not mentioned, right? The book doesn't contain anything in the neighborhood of this question. It doesn't falsify the idea. It just simply pretends there's nothing to talk about.
Yep.
And my point would be, under normal circumstance, let's say science screwed up badly, and that this thing somehow didn't get noticed 20 plus years after the fact. It finally dawns on somebody that
This thing being your paper.
yeah, my paper and the model that it proposes. Okay, so they're 20 years late. Shouldn't Gina Colada now be calling up the people who she interviewed to report this story and saying, wait a minute, was this predicted?
Mm-hmm.
You know, shouldn't she be digging up my paper and saying, wait a second, didn't I just report a story in which this appeared to be some brand new surprising result? And in fact, here I'm looking at a published paper in a respectable journal in which the exact thing is described ahead of time by 2 decades, right? Shouldn't that happen? Right?
Yes,
What
it
about,
should.
you know, where's Nicholas Wade? I certainly contacted him about this. Carl Zimmer. Shouldn't Carl Zimmer be buzzing with, wait a second, I heard about that 20 years ago. What happened? Why is this not in the story? And yet they're not going to, because this is a cozy club of people who are effectively, they are doling out scientific results at a rate that keeps them in their jobs. It does not serve the public.
Well, it wasn't supposed to be the science journalists' job to do this. There having been scientific malpractice, effectively, it then becomes the science journalist's job to discover the story and unearth it and figure out what it means. And sure, yes, absolutely, the science journalist should now be on it, but they're not. And I think, more to the point, when it's so clear that science, that the club of people that are doing science in any given domain is clearly just that. It's an insider's club, and you're either in or you're not. And if you're in, you're going to get your back patted and your grants granted, and your tenure review panel is going to be well stocked with friendlies, and you're going to proceed up the academic or perhaps corporate scientific ladder. And if you never had the expectation that your work would be challenged on the basis of whether or not it was good, if the entire game was played at the social level all along, that's not science. Science wasn't being done if it was entirely about who said that. If I like that guy, then that's a good thing he said. And if I don't like that guy, then that's not a good thing he said. That's not how science is supposed to work, because science is supposed to be about the process of discovering what is true, whether or not you like it. Whether or not the person saying the thing that is true is someone whom you like, whether or not the person who is saying the thing that is true is saying something that is true, but in other realms he says things that are unsavory. None of that is supposed to matter.
Yeah, it's not supposed to matter. And the fact that in this case, you're dealing with a bunch of things of consequence. And I agree with you that there's a level of complexity here that makes it hard to track. But
Sure.
Evolutionary biology scored a win, right? Correctly predicted things without the necessity of laboratory evidence. On the basis of theory alone, there are a small number of such predictions in the history of evolutionary biology. We get to add another one, right? It actually works, right? That's an important piece of evidence about how significant this is, how much we should invest in evolutionary theory.
Also, a bonus that it actually builds on one of the other major theoretical predictions, antagonistic pleiotropy, from
George Williams,
1967?
57.
57.
57.
Okay. Yeah.
Right. So this is a great story. It's a multi-generational story of success of an evolutionary line of reasoning, a very elegant one that ultimately arrives at a mechanism which you can validate in a laboratory study. That's pretty cool, right? It also, in the context of the hell that we have just gone through with COVID, right? You
The
and
world.
yes, you and I were entitled to bring that success. Let's say we'd lost our minds. You and I have lost our minds, but we hadn't lost our minds 20 years ago, right? We are entitled to say, hey, here's a past success, and here's one where it took 2 decades for the field to catch up, right? So that raises the question, right? Are we now nuts or are we just ahead, right? And the fact that this can be disappeared means that you and I are dismissible on the basis that, well, who are we? We're not even functioning academics, right? Okay, but so what? The point is, this is a significant success. And again, I don't want to be talking about this. I want somebody else to figure out whether this is significant, and I want to be able to stick to the scientific part of it. But if you've got effectively everybody across the board pretending that the hypothesis wasn't out there, that a interesting new result has emerged out of nowhere because some clever laboratory scientist thought to investigate the question, then the point is, well, okay, somebody's got to point out that there is in fact a hidden history here, which isn't all that hidden.
Well, and it also, so I have not read the New England Journal of Medicine article. I hadn't heard about any of this until shortly before we went on air here. But is it hypothesis driven? If it is, from whence the hypothesis is a question, and if it is not, this is not. I mean, you've already said it. I've already said it. We've already said it many, many times. But absent the preceding hypothesis, the work itself is not a test of anything. And so, if any time people with fancy machines and computers fast enough to run very high-powered statistical tests say, oh, I can just collect a whole bunch of data over in that sphere and then see if any pattern emerges when I tell the computer to do some stuff and go, aha, see, I found it. I go, what's that you found? Oh, well, it's the thing. Oh, let me see what I think that means. If you're trying to figure out what you think it means afterwards, that means that you were poking around in the dark. And poking around in the dark is not what science is supposed to be doing. Poking around in the dark is effectively, it's haphazard at best and random at worst.
This is poking around in a self-inflicted darkness, which is so strange because you think that scientists are out there trying to get ahead of each other and that's, it's sort of ugly that it's a competitive business, but it drives us to see things. These are people who are striving not to see what's in front of them. And here, let me show you. Zach, will you bring up the New York Times article, the Gina Colada article? Now scroll down below the picture. There's a picture of a woman who has this mutation. There's her. Okay, this is just at the limit of my being able to see it here.
Do you want me to read it?
Yeah.
From the beginning?
Yeah.
There were, though, some...
Sorry.
That wasn't you, I don't think.
No.
There were, though, some puzzlements. Do you want to read it now that it's big enough to read?
Yeah. Some organisms even have crazy long telomeres, like mice, said Dr. Benjamin Ebert, chairman of the medical oncology at the Dana-Farber Cancer Institute. And mice don't live that long. Okay? This is a sentence written in 2023 that says that mice have crazy long telomeres? Okay, now, can you bring up my article?
That's going to be on my computer, right? You have it? Okay.
And then, bring it up. And then scroll down to the end of the abstract, which I'm not going to be able to read. Maybe back up.
Yeah. With their telomere, stop moving it. Where do you want me to start reading from?
We observe that captive rodent breeding protocols designed to increase reproductive output simultaneously exert strong selection against reproductive senescence and virtually eliminate senescence that would otherwise favor tumor suppression. This
Virtually
appears to
eliminates
have...
selection.
Say again?
And virtually eliminates selection that would otherwise favor tumor suppression.
All right. This appears to have greatly elongated the telomeres of laboratory mice. With their telomeric failsafe effectively disabled, these animals are unreliable models of normal senescence and tumor formation. Safety tests employing these animals likely overestimate cancer risks and underestimate tissue damage and consequent accelerated senescence. So that is a scientific sentence. It was properly contextualized and was up to date in 2002. Mm-hmm. Gina Colada's article saying, in fact, there were paradoxes. Mice have crazy long telomeres and they don't have long lives. That is a sentence that would have been foolish 20 years ago. In the current context, with this other result now having been validated, a telomere-based Nobel Prize has been awarded. Carol Greider has given a Nobel lecture on telomere length in mice, in which she, like everything else here, describes things upside down. She pretends that the strangely long telomeres of laboratory mice are a good thing because of all the weird things they allow us to see. But nonetheless, it's not a secret, right? It is being dealt with in this bizarre way that prevents people from putting 2 and 2 together and getting 4. But nonetheless, it's not a secret. It's been discussed everywhere, but it's been discussed in a way that just does not allow credit to flow anywhere that is not preordained.
And it works in part because perhaps everyone, there may be a few odd people in the world for whom this is not true, but nearly everyone likes story, understands human interaction. And so this science journalism, so-called, is being told with quotations and a little bit of human interest and this and that and the other. And it's much more dry to keep up on the literature and go in and say, this is predicted here and here's what we have. It's much both easier and easier to sell the story to the editor, presumably, and to the readers of the New York Times. And, it would be the readers of anyone. I'm not particularly going after the readers of the New York Times here, to say, I'm gonna make a phone call to one of the trusty people in my, modern Rolodex, and get a quote that works and that feels really sciencey, and it also breaks up the, dense scientific speak. And oughtn't that be good enough? Because they're the people who are paid to keep up on literature, aren't they? And so the failure is, yes, at the journalism level, but first it's at the scientist level. It's at the level of the people who are supposed to be doing the science and who are claiming to be doing the science and who are holding the torch for science and letting it go out.
Yes, but, at the beginning of that, you alluded to the narrative. And the fact is, the narrative of evolutionary biology seeing something that laboratory science didn't see or refused to see, and it having dramatic implications about human health, about our capacity to do future science, right? That's a good story, and there's a reason that it doesn't show up. And it's not because it isn't a good story. It's because that story is threatening to something that is in a position to snuff it out.
Yeah.
And that is, I think, deeply troubling. It's not that human health does not ride on the question of, was this knowable, right? Mm-hmm. This was knowable. It was knowable 20 years ago. It had implications. It's important in, for example, you and I were taken to task by Eric Topol on Sam Harris's podcast. Well, Eric Topol became famous, I believe, in the fight over what happened with Vioxx. So in some sense, his coming after us is 2 schools of thought on what happened with the Vioxx scandal. And our school of thought has just scored a major triumph, but it will not be recorded that way. And therefore, Eric Topol will still come to the battle as, the highly decorated professor. And, you and I are, I don't know, people who went to a college where teaching was the primary thing and, left during some bizarre meltdown, right? That's not how it is. Scientifically speaking, there's actually a track record on both sides, and the implication couldn't be more important for issues in the present, like public health policy during COVID, like pharmaceutical safety over that same period, like the evolutionary implications of vaccinating into a pandemic and what that had to do with the proliferation of variants. The point is, you are supposed to take your track record into that battle. And when you say something surprising, your track record is supposed to cause people to calibrate, right? Are you a crank? Well, if so, newly so, right? Because there's a long track record of being right about things in this area, surprising things, important things.
It was part of why, as much as many in the scientific and medical establishment wanted to do so, it was hard to dismiss Kary Mullis out of hand when he started saying things across a number of fields that you weren't supposed to say. And of course, the idea that there are things that you aren't supposed to say in a scientific domain is itself distinctly and should be immediately suspect. Like, that tells you right there that you're not playing in science land anymore, that this is something else.
Yeah, Kary Mullis and Luc Montagnier. And I would say that to the extent that something like, Nobel Prizes are awarded for a reason, those guys both had one. And the point is, they came to any argument, no matter how counterintuitive what they were saying was, both of them came to the argument with the official sanction of the Nobel Prize. And that meant, yeah, they could easily be wrong. But the point is, the chances that they were wrong just because they didn't get it was pretty damn low, because they had gotten it to a level that exceeded what most people do in a career. And anyway, I guess I am simultaneously tickled to discover that, I gotta tell you, having been told as a graduate student that the fact that we grow feeble because we have a cancer protective mechanism, that idea wasn't interesting to nature's audience. I mean, it was obviously an insane thing for them to say at the time, but it is sort of fun to have the vindication of, oh, well, now everybody seems to be interested in that. Now that it didn't come from evolutionary science, it came from the laboratory. People are fascinated by this enough that the New York Times is all about it. But I am frustrated at the degree to which the failures of the system that is supposed to be the system in which peers are reviewing each other's work to make sure it meets a certain quality. One of the things peer review is supposed to do is that people familiar with the area are supposed to tell you, oh, you failed to cite that result and you didn't account for that thing. So they're supposed to know it, and they're supposed to hold each other's feet to the fire over it. And it's not supposed to make it into the publication like New England Journal of Medicine unless it has, reached a standard of carefulness and thoroughness that it justifies publication there. That system doesn't exist, right? That system is more likely to force you to exclude things in order to make it into the club so that you don't, rock the boat for those who are, at the top of the field. That is deeply frustrating to me. And having watched so much harm done over the COVID pandemic by bad science being sold by bad journalism, right? It's just, this feels like, it is simultaneously a wonderful vindication and a slap in the face.
Yeah, that is what it is. And a demonstration that many are resolved to have learned nothing, which means next time it will be worse.
Yes, and we're still learning nothing.
Yeah, continue to learn nothing.
Yeah.
All right. Let's just talk for a couple minutes about this one last thing.
Sure.
If we may. I think you have not read Louise Perry's most recent Unheard article. It's called Modernity is Making You Sterile. Is that right?
I have not read it.
So she's a fantastic writer and thinker. She, let me pull this up, wrote, don't show my screen just yet, Zach. She wrote the book, The Case Against the Sexual Revolution, and is host of a podcast that I had not heard of before looking at her byline here. The podcast is called Maiden, Mother, Matriarch, which is a fantastic name for a podcast. But I read this piece, and I'm going to read just the opening paragraphs for us today. And before doing so, I don't actually know her politics. I take her to probably be sort of a classical liberal, maybe a conservative, maybe a little bit right of center. I'm not really sure. I think this piece is, I'm gonna link to this in the show notes, and we won't talk about most of what's in this, but I find it just an excellent example of well-reasoned, tight scholarship, beautifully written. I disagree with a few of the points made rather strongly, agree with a whole lot of other ones, and feel like this is the perfect example of the kind of thing where can't people from all sides of the political spectrum come together in good faith with the data and stories and truths at our disposal and say, okay, where do we actually disagree in terms of the values? Rarely, more to the point, more often in terms of what the recommendations are for how to go forward. So I'm going to read just the first few paragraphs and then talk about one of the things, one of her suggestions in here that I sort of read like, oh God, no. But I also understand where she's coming from. So yeah, you can show it now. This is oh, did I say unheard? I'm sorry. This is The Spectator. Modernity is making you sterile. Rage against our demographic doom. Published May 7th of this year. Cassava is a woody shrub native to South America, Perry writes. For people living in drought-prone tropical regions, it is a godsend, delicious, calorie-dense, and highly productive. The indigenous peoples of the Americas who first cultivated cassava are reliant on it and have developed an arduous days-long process of preparation that involves scraping, grating, washing, and boiling the plant before it is eaten. At the beginning of the 17th century, the Portuguese introduced cassava to the Old World, but they did not import the ancient methods of processing, assuming that indigenous people were wasting their time. We do not always know why we do the things we do. This applies as much to indigenous peoples as to modern Westerners. The first cultivators of cassava could not explain why the scraping, grating, washing, and boiling process was necessary, but because they could not know, that every step of the process is essential in order to reduce the cyanide content in the plant. If even one step is skipped, chronic cyanide poisoning is the result. And the really devilish thing about cassava poisoning is that the buildup of cyanide in the body is so gradual that it is almost impossible to identify cassava as the culprit. That's the problem with what we all think of as progress. It swats away benevolent traditions because the usefulness of traditions can be subtle and hard to understand. Technology brings many blessings. Better medical treatment, better nutrition, and better comfort for all of the world's population, even in the poorest regions. But rapid technological development liquefies well-established traditions, and sometimes we don't realize what we've lost until it's too late. So that preamble reads, I mean, it's very much the message of our book, of course. We don't happen to tell the story of cassava in A Hunter-Gatherer's Guide to the 21st Century, but we tell many others that are like that. And the message is one that, of course, we resonate with because we were teaching that. We've been teaching that for decades and is what we wrote into our book.
Yeah, in fact, it lines up with both literally false, metaphorically true,
That's right.
and Chesterton's fence, which
That's right.
both play a large role in our book.
Yes. Chesterton's fence, for those who are new to listening to us, being it's I guess a parable from G.K. Chesterton, a early 20th century philosopher, writer, thinker, who tells a little story about two guys walking along and running into a fence. One of them says, it's in the way, let's get rid of it. The other one says, what's it here for? He says, I don't know, let's get rid of it. He says, you don't get rid of it until you know what it's there for. Only if you know what it's there for and can establish that the reason that it's there is no longer relevant, then we can talk about whether or not you can get rid of it. Until and unless you know why it's there, you don't touch it. So it's a inverse while pushing in the same direction as the precautionary principle.
Yep.
So you can, if you would give me my screen back here for a second. She goes through an analysis that we've got vast fertility declines, especially in the weird world, Western, educated, industrialized, rich, and democratic. We have, actually, I'm not sure that we've talked publicly about the reality, actually, that there are two simultaneous population crises on the planet that go in opposite directions and yet completely do not cancel each other out. And so, she's talking about the fertility declines, which suggest a looming demographic disaster, but it's also true that there are too many people. on the planet to be supported in a manner that can allow us all to be healthy, eating good food, having access to the kinds of things that most Westerners want access to.
Yeah, I would, because I know what trouble we're going to get in over that claim, I would say the point is really a consumption. There's too much consumption, and the problem is that the technology to allow that number of people to coexist on the planet without consuming at a rate that is unsustainable doesn't yet exist. Now, it's not inconceivable that it could, but at the moment, it seems like too many people because the rate of consumption requires a destructive interaction with the planet.
Yes.
Like that.
Okay, so then she talks about some of the ways, not all of the ways. We actually talk about a number of other ways that modernity is affecting our standard of our quality of life, but also our fertility. And she talks about some of them, and one of them she puts on the doorstep of modern feminism, the kind of feminism, sort of third wave feminism. She doesn't call it that, but that I always used to call faux feminism, FAUX feminism, not FOE, although it kind of works either way. But this sort of feminism that forgets history, forgets what we are, just wants to prioritize doing what you do when you want to do it, and looks really naive as a result. Perry frames this as a kind of freedom first, like freedom, individual freedom as the primary thing that is desirable in feminism. And she writes, we need to marry modernity with a culture that promotes and supports parenthood. And you can show my screen if you want, but you don't have to because it's just one paragraph. A feminism that prioritizes freedom above all other values will never be able to achieve this goal, which is why we need to be fashioning a feminism oriented towards care and interdependency. Orientated, she writes. And if we are going to attempt this, then we will need to look at people of other times and places with new eyes. And rather than assuming that they were all bad and stupid, as the progress narrative does, instead thinking carefully about which norms and institutions actually serve the interests of women. In pre-modern Europe, women would remain in their homes for the first 40 days after giving birth, in a period known in English as lying in. Initially, they would stay in their beds and in their bedrooms with female relatives, neighbors, and for the wealthy, servants, temporarily moving into the home and tending to their needs and the new babies. Okay, if I may have my screen back now. She then advocates for this, and she reports on how demanding very early motherhood is, and how she herself ended up being alone in some medical need, but also with a newborn after her husband went back to work, and advocating for, basically both antibiotics and lying in. And I read about the lying in thing, which I've heard before, and I think I literally shuddered with horror. As you can imagine,
yes.
I would have.
Wouldn't have been your thing.
The idea that you would be literally imprisoned in your home, not allowed to go outside in the month or month and a half after your child was born, sounds like complete hell to me, and also sounds deeply, deeply unhealthy. Will there be circumstances of the birth, of the pregnancy, of the baby, of what is happening outside the home, where that might be exactly what is warranted? Sure, absolutely. But for most women whom I knew, who had relatively easy pregnancies and relatively easy births and had healthy babies, the idea that you should be stuck first in your bedroom and then in your home and not going outside with your new baby, and that means the new baby doesn't get to go outside either, doesn't get to get any sunlight on his face, doesn't feel fresh air, anything, that looks like a recipe for ill health, for disease, actually. And again, there may be circumstances in which that lying in period would be good, but the idea of, we need to go back to that. No, we do not. The idea that we should be recognizing that isolating new mothers with newborns, especially if they have no support, especially if they also have reason that they shouldn't be moving around very much, is of course going to make it harder on new mothers. And you might see, for instance, a rise in, postpartum depression. Obviously, this is a problem of the way that we are encouraging people to mother now, as opposed to something that was going on 5,000 years ago, 10,000 years ago. How common was postpartum depression 5,000 years ago? Not very, right? It wasn't a thing. And no, I can't have the data to support that, but I am certain of this.
So there's a lot. I mean, it's not
There's a ton here.
surprising.
Yeah.
Mary Harrington and Louise Perry are friends, and
Right.
obviously
Yeah.
there's a lot of overlap in their perspectives. And this reminds me a little bit of the conversation that I had with Mary Harrington. And, there's a question. There's nowhere to go back to.
Right.
One has to go forward. Going forward is a problem because of the precautionary principle, which is not easy to adhere to, because of Chesterton's fence, which is not easy to adhere to.
Right.
But at some level, we need to get serious about solving this problem. What do you do when the current way is not viable? Backwards doesn't work for various reasons, because we don't live in the same place, for one thing.
But also, it wasn't all that.
Well, let's put it this way.
Some ancient traditions are awesome.
Yeah.
But the idea that traditional gender roles are what we should be aspiring to
Right.
is anathema to a lot of people who aren't crazy insane with third wave feminism.
Yep. There's nowhere to go back to. There just literally isn't. And so there's a question about how you deal, without oversimplifying the problem, how you deal with the discovery of a new way that does retain the values that were correctly prioritized in the old ways without ever being explained, right? How you hybridize that with a new world in which some of the parameters have simply radically shifted. That's not an easy job. And one of the things I greatly appreciated about Mary Harrington was that she was absolutely ready to have that discussion.
Right.
She has a bias about effectively thinking that not only should we go back, but we should go back farther than we think. But the discussion that ensued around the question of, well, that is actually not possible. What do we do going forward, given that, for example, birth control is going nowhere, right? That is a radical change, and it alters the entire landscape here. What would it look like to succeed going forward in defining a new mechanism for being that preserved what used to exist that worked and replaces that which used to work and doesn't anymore, or what doesn't work in the present?
I guess I will also say, I don't think it's a hedge, but just anecdotally with regard to our situation. In the case of both of our boys' births, my mother came up either just in advance or to her great sorrow hours after the birth, and stayed for many weeks. You are as active and participatory a co-parent as any man I have ever met. And even at that stage where there was a lot of stuff to do with parenting that you just don't have the anatomy and physiology to do, you were very, very present. And also, there were a number of mostly women, but also some men at what was still a functional college that was both of our employers at that time. And in both cases, they organized and brought in a number of, a couple of weeks of dinners for us. And so we did have some support. Now, during the day, I was strapping the baby to me and going out on walks because that was what I needed to do. That was what felt healthy. But without you being who you were, without my mother there, without the support of our friends and colleagues, it would have felt a very, very different thing. And so there is no argument. I would never make an argument, nor would I think it would be sane to do so, that a woman should just go into motherhood totally solo and expect it's going to be fine. That makes no sense.
Yeah, that has never made any sense.
Yeah.
I would also point out, though, that it's weird, the idea of laying in, right? Okay, that's some arbitrary moment in the past in some particular continent. But hold on.
She argues that and I don't know that this is true, but she argues that it was nearly ubiquitous across cultures. I have not run into that before, but that is the argument in this piece.
Well, then here's the question. Okay, virtually every hunter-gatherer society, maybe even every hunter-gatherer society, at least the ones I'm aware of, babies are carried passively as mothers go on about their hunting and gathering, right? And this has lots of potential benefits, right? For one thing, there's lots of subtle stuff that gets communicated, rhythms of life, kinds of things, just the experience of, we spend a certain amount of time in this kind of activity or that kind of activity. I one of the ones I found most interesting was that babies and mothers establish a kind of communication about the baby's need to poop and piss that allows for a diaperless world in which you're not constantly running into terrible things because, when the baby needs to go, it subtly lets its mother know this. The mother finds an appropriate place. No diaper is necessary. Yeah. This becomes impossible in a modern society.
In the land of sheets.
Right. In the land of elevators and offices and sidewalks and all sorts of things that then result in us making the very terrible choice to effectively tape the feces to the baby. That's not a normal thing to do, but it also results in the baby losing touch. So if a baby would naturally be in touch with its own need to excrete things, and then it loses touch with it because we effectively cannot allow the baby to be doing that anywhere and everywhere, as a hunter-gatherer could, then we have to reteach them, these things, which is an unnatural and broken mechanism. And
it's fun for no one.
Fun for no one, yes. But anyway, the point is, where are we? Well, you can't go back, right? We're stuck with the fact that many people live in modern circumstances where they can't just behave like a hunter-gatherer. Going back to a laying-in period indoors where, I'm sure that if you were laying in...
I think it's lying in, at least as she spells it here.
All right. Lying in, if you were lying in, presumably in Europe, how many hundred years ago are we talking about?
Until relatively recently, but I think she may have said medieval. I'm not sure.
Medieval. So, at the very least, certainly if it was winter, probably almost any time, there'd be a fire, which, has some sort of positive benefit. The point is, we are at an arbitrary place in technology all the time, right? And that arbitrary place...
This is a very important point, actually, that it feels to everyone, presumably, like we've arrived, we are here. We are the moderns, we have arrived, and from here on out, it looks the same going forward. But man, there's a lot of change. Yesterday looked different, and a week ago looked really different, and a month, and wow. But good to have arrived right now, right here, because now things stop.
Now we're modern. You can relax. Which turns out not to be true.
Right.
Have I introduced you to the AI? But yeah, we are now always somewhere arbitrary. And so what the upshot of that is necessarily as fraught with danger as picking and choosing from the arbitrary collection of options is, and it's not going to be good. I mean, she opens with a killer point in this piece, right? The cassava story is definitely a beautiful example of the Chesterton Spence issue.
No, and the hubris, which until recently was always, those natives, they just don't know what they're doing. And now it is revealed that actually the hubris goes every way, all the time, constantly. We're always assuming we know more than we actually do. And maybe don't mess with that until you, never mind.
Oh, the natives don't know what they're doing. Go nixtamalize yourself.
You might want to spell that out.
It's a corn processing methodology that makes the beast properly digestible. And
did you say beast?
Yes. You don't think corn is a beast?
No.
All right. Well,
and it's referred to as liming.
Yep.
Right. Liming of corn.
In any case, I think and you and I spelled this out really directly in the book. Can't go back. There's nowhere to go back to. And going forward is not going to be there's not a method for doing that in a way that is without carnage. But, going back, full of carnage. Going forward is going to be full of carnage. The question is, how do you minimize that amount of carnage and not keep repeating the same errors, right? How do you learn from those errors? And, at some level, rein in the impulse to embrace the new because it does seem improved. Right? Compact fluorescent light bulbs. Really? You want to stop eating tuna? You've got mercury that's suddenly in the environment at such a level that tuna fish is a concern. That really shouldn't be. Let's replace it with LEDs. LEDs, they're super efficient. That'll be great for our carbon footprint. But how is it for our physiological health?
There was, and I did not to talk about this, but I understand that there's a new piece of legislation being pushed forward, or maybe it's not legislation, some new standards being pushed forward by the Biden administration to lower what I think is actually already a pretty low number of maximum gallons that is going to be allowed to be used in any standard running of a dishwasher. And the time period during which all dishwasher manufacturers have to abide by this thing is something alarmingly short, like 3 years. And
For all new dishwashers.
all new dishwashers, yes. I don't think anyone is going to come into our homes and steal our dishwashers from us. I don't think. I didn't say it won't happen. I said I don't think.
Yeah.
Yes. New dishwasher standards. I think, again, I didn't prepare this. I think it was like at 5 gallons, already like Energy Star, like it was water consumption was already a concern. And now it's going to go down to something like 3.5 for full 3.5 gallons per cycle. And again, I may have those numbers wrong, but this struck me as so naive, so unaware of even the most basic trade-offs, that it's just one thing after another with politicians at this point. Like, really? Water is the only thing you care about? What do you think the water is doing? Have you ever washed a dish by hand? Can you simply reduce the amount of water you use by a third and have it work just as well? If you can, you really weren't being efficient in the first place. But there's already efficiency standards on these machines. So it's not like these are water guzzling machines now. If they were, okay, you cut it down, you cut it down, you cut it down. But there are places where water is not that limiting. And you know what is always a problem is the detergents. So it's water and it's detergents. And what's all in those detergents? A lot of nasty things. Where do they go? Are you going to need to use more of those if you use less water? Probably. I'd rather use a little bit more water and less of this crap. Totally, right?
Yeah, and
so water, reduce the water use. Why? Because you can spell water and you know what it is and everyone has an idea of what it is. Like, this is so backwards. Everything about these political, just like, we care about the environment because we're reducing water consumption. I can reframe that to make it clear that you don't give a rat's ass about the environment by doing this.
Yeah. It is oddly the same thing we ran into with COVID policy, where there was an obsession with, antibody titers or something that did not properly take a integrative measure like all-cause mortality. Right?
Exactly,
we have
right.
some measure
Yes.
that would actually be worth shooting for an improvement in. And instead, we're going to measure something else because it allows us to say a lot of complex stuff that doesn't turn out to be true. Like,
Yes. Yes.
okay, this energy has an R rating of such and such, right? It's therefore better than this other one who has an R rating that makes it, 20% less efficient. Okay, but how often do you have to replace the sealed panes because they've gotten a leak? And where does the energy in the production of those panes figure into the equation? You want just some sort of net analysis, right? Yes, it's terrible to waste water because it's expensive to procure, and we do a lot of throwing away of perfectly drinkable water. Even as we're polluting our water and requiring people to do their own filtering and all of this nonsense. But it's not like we are, for some reason, making all of these puzzles harder than they actually are.
Yes, while standing up next to some simple graphic that looks like it'll help people get elected next cycle, which, that's an old game. That's an old story. That's nothing new. But it seems like the pace of these things coming out and the obvious naivete, and that's being kind, that is behind these things is ever more clear.
Yeah.
All right. Well, on that happy note, let us bid you adieu.
We can return to a spring.
Yes, we are going to return to spring. We hope that you too can return to spring, although
unless you're in the southern hemisphere, then fall it is.
Yes, and for most of you, it's probably it's later than it is for us, but still, it's gorgeous here. If you're in the Pacific Northwest, anywhere in the Sailor Sea, or anywhere along the west coast of the U.S., do join us next time. We'll be back on Saturday, which is May something. It's going to be the 14th, maybe? No, the 13th, I think. And we'll be back then, along with a Q&A. And until we see you next time, be good to the ones you love, eat good food, and get outside.
See you in the future.